Hi everyone, welcome to today's ETABS API tutorial. In this session, we will dive into using the ETABS API to automate the creation of structural models, especially a sloped-roof warehouse. Modeling such structures in ETABS can be time-consuming and labor-intensive. However, if the model follows a repetitive pattern like that of a warehouse, we can streamline the process through automation. Let's get started. But before we go further, if you are new to the channel, make sure to check out our extensive collection of videos on ETABS API and plugins. Links are in the description down below. Well, as you see here, we already have a warehouse model. It has 3 spans in X direction here and 7 spans in Y direction. I want to write a code in which no matter how many spans we have in both axes or to what extent the slope is, the code is capable of assembling the model in less than a second, saving us some time. Okay, if we go to the coding part, this is the code and this is the Windows form. Let's click on Start here to showcase how it initially works, and then we get to the coding part. There are some text boxes and buttons, and these text boxes are to read inputs like number of spans in both directions, length of each span, and height of the column. Here, for example, this one here, bottom story height is the height of this point here relative to the base. And then typical story height is the height of this point relative to this point here. Okay, and by the way, the unit following is meter. Now hit the create the model button to create a model. For example, I want to have for the number of span in X direction, I want it to be 4. Number of span in Y direction, I want it to be 2. Bottom story height, for example, 6 meters is good. Spacing in Y direction and spacing in X direction, I leave it this way, and then create the model. Okay, it takes time to launch ETABS and create a model. It depends on the computing level of your system. Here we go. The model is perfectly done. And if we go back to the form here, and then if we click on select BF columns button, then it selects all the column in the front and back side of the model. So it is a good idea to have some shortcut to select some elements of the model in order to change some qualities of the model. So it is an example here to show you how we can select some elements in the code. I show you how it works when we get to this part. So now go back to the coding part in Visual Studio. Let's get to the hard parts. Okay. I here stop the debugging here. Okay, before you start to add any lines of code, you need to add ETABS reference to the project. Here On Solution Explorer, click right-click on the name of the project and then click on Add Reference. Okay, a window will pop up and you need to go to the browser and find ETABS v1.dll from the path your ETABS installed. I have it already here, but if you are going to use the ETABS API for the first time, click on Browse here, go to where your ETABS is installed, and then find ETABS v1.dll. Choose this one, click on Add, and then click on ETABS v1.dll, and then click on OK. So I've done it before, then now I click on Cancel here. Now go to Reference here to check whether ETABS v1 reference is added to the model or not. Make sure it is added perfectly. Now go to the coding page. You have to write using ETABS v1 in order to use ETABS namespace. It enables you to have access to the ETABS namespaces. Okay, and here I added two very important objects using ETABS namespace. The first one is an instance of COAPI class, and the second one is an instance of CSAP model class. And these two are essential in any app working with ETABS API. Next here, I defined some variables to store information read from text boxes in the Windows form here, like number of lines in x-axis, number of lines in y-axis, number of the span in x direction, number of span, stuff like that. Okay, and by the way, all the code here is available for you to download. Link in description down below. You can explore the code as long as you want and change the code in order in your favor. So, and then we get to this part here. I defined a method in order to launch ETABS. So it has a CSAP model object as a return object. So, and there is no, as you see here, there is no input here, but here these 4 lines of code are for launching the ETABS. Through these ones I store, and then through these ones here I store information read from text boxes. And the next part here, I use those variables above to create grid lines. Here, my SAP model dot initialize new model. Here, I initialize a new model using a specific unit. You can use the specific unit to launch ETABS, or you can leave it empty. If you leave this part empty, the ETABS will use imperial units. And then here, as you see, I set this part is also important. If you want to read any information from the ETABS model, you have to set unit of the model. So I use Newton as the force, meter as a unit for length, and Celsius as a unit for temperature here. And then this is very important here, my SAP model.file.new grid only. This is a method that we use to create grid lines. as you see, the first number is number of stories, the second one is a typical story height, the third one is bottom story height, then number of lines in x-axis, number of lines in y-axis, and then spacing in x direction and spacing in y direction. I read all those information from the text boxes. Here I saved them in these variables here, and then I use them in order to create grid lines. Okay, and well, so far so good. And what is next is totally related to how the geometry of the warehouse is going to be applied. First, I get to add columns of the model. This code here, my submodel.frameObject.add by core. This code here receives the coordinates of both two ends of the element. Once again, because it has a repetitive pattern, we can use loops and stuff like that to manage to extracting each element coordinates. And by the way, ETABS has a numbering system to be added to any element. It gives every element a unique name, and it completely depends on when you define that element. So it has a consecutive order. It is important to know because you may want to change the section or any other properties of a specific element further in your code, but you don't know how to recall the unique name of the element. All that being said, ETABS has a straightforward approach to it. For example, the first element added has a unique name 1, and the 100th element added has a unique name 100. So this is a very important part when you want to model a structure in ETABS through ETABS API, because you have to change some qualities of some elements further in your code and in your application. So you have to create a way to recall, to save each element's unique name, and find a way and create a way to recall that number. Okay, well, next part, slope beams are added. Slope by slope beams, I mean these beams like this one are added to the model. And then we get to, and all of that, we use this line of code, my submodel frame.frameObject.add by core. So it receives the coordinates of the first both ends of the element. So x, y, z for the first node of the element, and x, y, z, x, y, z for the second node of the element. And then, okay, we get to the front and back column in the middle of each span. So some warehouses have this kind of column in the middle of each span in order to attach some doors and stuff like that to the warehouse. And by the way, these columns are capable of conveying wind forces to bracing element here in the roof. So, okay, get back to the code. And by the way, I want to say it again that this is all about geometry. For example, use here, this is a loop that I want from I1 to I number of the span in X direction, and through each loop I add new elements of the front and back column. So this is all about geometry. It's sometimes very difficult to introduce it to you, to explain it to you. If you have to find it, you have to find a way in your way to model a repetitive a structure that has a repetitive pattern like warehouse. Or if you want to understand these, for example, these things here, I minus 1, then multiply by spacing x, you have to dive into the geometry of each element. For example, this is not that difficult to get to know how to extract both ends of each element of the warehouse. So I think if you want to get it, you can understand it from this code, or you can just leave it that way and use this code, or you can have your way to model the warehouse. So okay, then okay, the next part, slope beams are added, and then roof bracing elements, and finally here, if we get if we scroll down here, for example, here, okay, it is bracing in Z plane. This one's sorry, here, for example, okay, these elements here, yes, these ones. These elements here are the bracing elements in Z plane. These one is bracing elements, roof brace. These are bracing roof bracing elements, and okay, I think all of them are clear to understand. Okay, and then okay, some elements, especially roof bracing, are pinned to one another or to sloped beams elements. This is a typical way to erect and build warehouses, and so we need to change the connectivity and the release moment resistance in both end of bracing elements. As I mentioned before, you need to add each element with harness what unique name it gets. So when you want to change some qualities of the element, you refer to it correctly. So here I defined a loop to navigate through all bracing elements here. This one here, I mean, and this method here, my SAP model, that frame object that set releases, is used to assign each end's connectivity. This Boolean type variables here gets connectivity status with true or false. For example, these three these three cells in the array are related to connectivity status of moving in three local axes, moving in X, Y, Z axis, and these three last cells are related to connectivity status of rotating in three local axes. This is very important to understand. The first one is moving in X direction, Y direction, Z direction, rotation about X axis, and you keep in mind that all these coordinate or these axes are in local axis, not general axis. And for example, the last two here, this is about moment about two axes, and this one is a moment about three axes. So 2 and 3 are referring to the local axis of each element. Okay. And if you want to know more about the local access of ETABS, you can just search on Google that. Just write down local access of ETABS. It gives you some information about the definition of local access in ETABS as well to you. So then, and okay, here I release moment resistance around local access to here. So the moment about local access to is released, there is no resistance for moment, and there is no resistance against rotation around 3 axis. So basically, it is a pinned connection. So when you have no rotation, when you allow rotation to be happen, it is a pinned connection. Next, the boundary conditions are determined. By boundary conditions, I mean the connectivity status of base of each column to the ground. So I want all columns to be fully restrained at the base except these columns here. These columns, I want these columns to be pinned to the ground. So then here to this loop here and this line of code here, we can select the points and this array and this array of Boolean values here determines the degree of freedom of each node or point. I want a node to be fully rigid, so all value here should be true. Here true means you create a by true means you block the degree of freedom. And by the way, likewise the previous part, the Boolean array consists of 6 degrees of freedom. The first 3 of them are related to displacement, and the last 3 of them are related to rotation, and all of them are in local access. This is very important that you have to in your mind. Well, now, okay, this part is also done. I forgot something to mention, and here this I defined some variables here in order to count a number of each part that I defined in previous parts. For example, all columns, I count all the columns, all diagonal member, all front and back column elements, all roof bracing in y direction, all roof bracing diagonal bracing, and by diagonal I mean these ones, and by roof bracing alongside the y-axis I mean these ones here. And all bracing in z-plane. Okay, all bracing in the, sorry, I have 2 different tabs already open, so I jump in 2 of them simultaneously. It may makes you confused. Okay, and this type of element here, I mean by bracing in z plane, I mean these type of elements here, these 2. Okay, this is also done. And the next method here, so this method is done. The model can be created by all these methods and line of code above. So here, this method here, this is about running the previous method. Okay, so the previous method as an event after bottom create ETABS model. So we run the create ETABS model method here, that we have it here as an event of the button that we defined here, this one, create the model. So, okay, so far so good. Before we proceed, when the model becomes so large, it is usually very hard to apply loading and assign section properties. It takes time and effort, so it will be a good idea if there is a button to select elements that are similar to each other loading-wise. For example, these columns here, for example, this one, and this one, except the columns in the corner. These columns along the x-axis on both back and front side of the model are likely to experience same wind load and end up with same section properties. To address this, in the next method, I use here. I use this line of code here, my SAP model frame object that's selected, to select specific columns, not just specific columns, specific elements. So we need their unique numbers, as I mentioned earlier. This is very important. I previously talked about it to do so. For example, here k dot to a string is referring to the unique number of these columns here that I want to select. So, okay, for this reason that I need to define all these variables here in order to navigate to unique number of elements that I defined earlier. And as I said, mentioned that ETABS has a straightforward pattern to give each element a unique name. If you define this column, for example, here, if you define this column here first, it gives it a unique number 1. So my model is going to be something like that. I first define this column, then I define this column, then I define this column, and go up to this column here, and then go back here. Then I define this column and go to all down here to define this column at this corner. And then I defined some codes to create these elements here. Then I create this element here, sloped beamline mean, that I introduced them to the code as a sloped beam. And when the sloped beam are finished, I get to this elements here. When these elements that are aligned with y direction are finished, then I get to this kind of element here. I mean this roof bracing elements. And when these roof bracing elements are done, I get to this part, the bracing elements alongside the z directions. So this is how I managed to implement the creation of the model, and also finding a way to recall the unique number of each element. So I know when they are modeled to the ETABS, so I know the unique name of them, because it has a consecutive order. If it is so easy, I think you get it now. You get it now, that how it works and how it is done. Okay, this is all done. And then here, okay, I defined also a button to close the program as well. I think you know in this part of the program as well. It is not that hard. I gave a new value to my sap model and my ETABS model that I created. Yeah, it is also important to give them a new value that if you want to run the application, for example, 4 times through eternity, you have to this part here. So, okay, that's all. Today we got to do more real-world app with ETABS API. If you go back to my other ETABS API collection, you will find more information about ETABS API, ETABS API also in coordination with Microsoft Office Word in order to create a customized report. You can also find some beneficial information about the Microsoft Office Word automation and ETABS automation as well. And I insist you again to check out my other ETABS API tutorials, which is very important because you can find them more insights. And at the end, if you find this informative and helpful, please consider subscribing to the channel and hitting the thumbs up button. And I wish you a good day ahead of you and see you soon. Bye.